Hello everyone. Today we will study series and the parallel circuits. So this is a digital multimeter to measure current, voltage, resistance, and voltage. And we have three resistors, 50 ohm, 10 ohm, and 20 ohm. And this is the battery we will use. And actually we will just use the 1.5 volt and some cables here. This DMM can measure both AC and DC current and voltage. So today we use the battery. So this is direct current DC, and the maximum current is less than 200 milliampere. So we're going to use this switch. This is direct current and a maximum of 200 milliampere. So ammeter is polarized, so the current enter from positive. So milliampere, we will use this one. So if the current is very large, we will use the 10 ampere connection. But today the 200 milliampere. So current enter the ammeter here and come out from the COM. First, I'm going to build a series circuit, ammeter, resistor, and battery connected in series. Battery is polarized, so the current comes out from the positive side and enters the ammeter, come out, go through resistor. Resistor has no positive and negative side, so it's okay to connect either direction. Okay, now I have a series circuit. So this is my battery, go through ammeter to measure the current. So the current is 16.8 milliampere, and go through resistor, through resistor, and come back to the negative side of the battery. Theoretically, the current is the same everywhere in this circuit. To test that idea, I'm going to change the position of the ammeter. Now I have my ammeter at between two resistors. So now the current is still 16.8 ampere. Next, I'm going to put this one at another position. Back to the battery. Now this is the again series circuit, but my ammeter is at this position between the negative side of the battery and a third resistor. So you see the current is still 16.8 milliampere. I change the position, it doesn't change the current. So current is the same everywhere in a series circuit. Next, I'm going to use a voltmeter to measure the potential difference across each resistor and across the battery. So this is again DMM. This time I'm going to use it to measure voltage. So the maximum voltage is less than 2 volts. Therefore, I'm going to use this 2 volt direct current. So for voltmeter, the current, the voltmeter. So this is the positive side. This is for V and COM. That's always the negative side. So basically, the device measures the potential difference between the. Okay, next I'm going to use this voltmeter to measure the voltage across each device. So I'm going to close the circuit now. So I will start with the battery. So the voltage across the battery. So to measure the voltmeter, I put it in parallel with the device. So now I want to measure the battery, so that's positive, negative. So the resistance, the voltage across the battery is 1.398. Next, I'm going to check another resistor. The resistor. So this is the voltmeter connected in parallel with the 50 ohm resistor. So the voltage is 0.8464. Next, I'm going to use the DMM to measure resistance of this circuit. So this time I don't need the battery and I don't need the ammeter. So now I have 3 resistors connected in series, so without battery, without ammeter. So I can use this DMM to measure resistance. So I'm going to switch to measure resistance. So this side, this is the ohm. Ohm is the unit of resistance. So the maximum I get is less than 200. So I'm going to use the 200 ohm. That's the maximum resistance this device can measure at this setting. So the connection ohmmeter positive side is still this one because there is ohm sign here and the black one here. But actually for resistance, it doesn't matter about negative or positive side. So these 2 ends are open. So I'm going to click this point and click this point. So now the equivalent resistance. Now the equivalent resistance of the 3 resistors connected in series, 79. Next, I'm going to use DMM to measure the individual resistance. So I'm going to start with the 10 ohm one. It's actually 10.1 ohms. This is a parallel circuit. I have a battery current come out of the battery. This is the ammeter, and current split here. Part of the current go to the 20 ohm resistor, part of the current go to this 50 ohm resistor, and then it combine back at this point and go back to the battery. So the ammeter is here to measure the current that goes through the battery. So now it's 83 milliampere. This one, I have the ammeter connected in series with the 20 ohm resistor. So the amp current is 61.2 milliamp. Now I have ammeter connected in series with the 50 ohm resistor. Current is 25.9 milliampere. Next, I'm going to use DMM to measure the voltage across each resistor and the voltage across the battery. I'm going to start with the battery. So parallel with the battery. So the voltage is the 1.348. This is the voltage across the 20 ohm resistor. That's 1.346. Next, I'm going to measure the resistance of 2 resistors connected in parallel. So I disconnected the battery. I'm going to use the ohmmeter setting. It's maximum 200 ohms. And let's try here. Now the equivalent resistance of these 2 resistors connected in parallel, 14.3 ohms. This is the third circuit, the combination circuit. I have a battery current come out, go through the ammeter, and then go through the first resistor 50 ohm, and then come into the resistor 10 ohm. Here there is a split of current. Part of them go to the 10 ohm and back to the negative side of the battery, and part of them go to this resistor 20 ohm and back to the circuit. So now I have a 10 ohm and 20 ohm. They are connected in parallel, and both together, and the battery, ammeter, resistor 50 ohm, that's connected in series. So now this is the current that goes through the battery and the current goes through the 50 ohm, 23.4 milliampere. Now this time I have my ammeter at a different position, and if you look at the connection, the ammeter is connected in series with the 10 ohm resistor. So this is the current through the 10 ohm resistor. This time I have the ammeter connected in series with the 20 ohm resistor, and the current is 7.4 milliampere. Next, I'm going to use the voltmeter to measure the voltage across these two resistors that's connected in parallel. So I have a voltmeter setting maximum 2 volts, and the positive side right side, negative the left. So first one, I'm going to measure the voltage across the battery. Now I have the battery and the voltmeter in parallel. Now I have the voltmeter in parallel with the 20 ohm resistor. Now I have the voltmeter in parallel with the 10 ohm resistor. So the voltage is 0.161 volt. Next, I'm going to measure the equivalent resistance of this combination. These two resistors in parallel and connect in series with the third one. So disconnect the battery. This is the ohmmeter. I'm going to switch this one to measure resistance, maximum 200 ohm, and positive here and negative here. Actually, for resistance, it doesn't matter, positive, negative. So now let's see. I have this side and this side open. So I put it here, I put it here. This is the equivalent resistance of this combination circuit.